Satellite technology has come to the farmer's field in the form of this vegetation detecting sprayer. This sprayer only detects green vegetation in the field, but cannot distinguish between weeds and non-weeds. Red and near-infrared light sensors are used to discriminate between bare soil, crop stubble, and green vegetation. This allows the spraying of no-till or reduced-till fields where it's desired to burn off the existing green vegetation before planting or after harvest. By using this system, crop chemicals are only applied when green vegetation is evident.
This particular piece of equipment only detects the green vegetation, so it only sprays or turns on where there is green vegetation. Consequently, you have a reduction in the amount of chemical that's used. It's very environmentally friendly because you are only using spray where you absolutely have to, and there's no overspray or spray left around on the soil where it's not needed.
The system consists of a basic sprayer with some additional components and electronics. Each nozzle is individually controlled by a downward-looking sensor, which is mounted ahead of the nozzle and continuously scans the ground surface below. The sensors are adjusted such that their field of view overlaps to prevent plants being missed. Here's how it works. When green vegetation is detected, a signal is sent to the controller. The controller receives signals from the sensors on the boom and from an upward-facing sensor and compares the incoming incandescence from above with that being reflected from the ground. Green vegetation absorbs the red and reflects the near-infrared parts of the light spectrum. Bare soil absorbs both the red and near-infrared, while stubble reflects both the red and the near-infrared. When a difference exists between the red and the near-infrared levels, the controller activates a solenoid which allows spray material through the nozzle. As the machine travels across the field, each nozzle operates independently to spray detected plants. Individual LEDs show the operator when nozzles are on. This also helps in fine-tuning the system on the go. The operator can adjust the sensitivity of the sensors through the controller based on the available incoming light and field conditions. Evaluations in the field were carried out in no-till planting of corn and soybeans. Depending on the weed pressure, the amount of chemical used was 25 to 75% of full overall spraying in the same area. In all cases, there was good weed control with no significant differences between detecting spray and full spraying. The sensors will pick up vegetation that covers more than 3% of the field of view area. This means that small emerging weeds may go undetected. A simple solution exists which will get the small plants. By adding a second boom, which sprays overall, behind the detecting spray boom, the emerging weeds and small plants not detected will be hit. In this sprayer, the auxiliary boom delivers approximately 25% of the intended application rate, and the detecting nozzles deliver 75% of the intended rate. In doing so, the large detected plants get the full application rate, while the small and emerging plants get a reduced rate, which is enough for control. The expectation is a reduction of overall chemical application with complete weed control.
One of the things that came through, I guess, is that we can now use a chemical like Roundup as a desiccant in wheat and soybeans. So I see us going into wheat and soybean fields that have matured and browned off, and then spraying the weeds that are left, the green weeds that are left. This will certainly help with the weed control, but also where there's a lot of weeds, will assist in the combining, etc., because we'll be able to knock those weeds down before we actually get into combine. So I see that as a great benefit to us. Parking lots that have grass growing up in them, airfields, railroad tracks, roadsides, these are all areas that certainly could make use of it. The unit that we've been evaluating actually is owned by the Rondo Agricultural Conservation Corporation, which is a group of farmers who have got together to specifically do evaluations of various conservation tillage methods, planting, and so on, and the use, of course, using herbicides and chemicals for weed control, trying to reduce that, but also trying to reduce their inputs so far as cultivation and so on. So they actually own the equipment. The college and the engineering section have been responsible for giving technical help and advice in operating it and also in doing some of the test work.